elevator, you know how to draw free body diagram?
Slightly remember, sir.
You're not having clarity in writing free body diagram also.
No, sir.
Free body diagram is very important when it comes to entire physics, mechanics, at least for us. Even in electromagnetism also, free body diagram is very important in solving numerous applications.
Yes, sir.
So if you ask me how to draw a free body diagram, you know Newton's first law, second law, and third law, isn't it?
Yes, sir.
Free body diagram is making a body separate, making or whatever the required system separate from the world. We'll try to draw all the forces that are acting on the system or that particular body.
Yes, sir.
Because we know Newton's second law, which states F net external force is equal to rate of change of momentum. Okay.
Yes, sir.
This is Newton's second law.
Yes, sir.
F net external is equal to this external force. To find out this external force, we draw free body diagram, which is a simple way in finding out net external force, drawing free body diagram. And we'll find out the rate of change of momentum of the body or the system.
Yes, sir.
The rate of change of momentum, here actually in Newton's law, we study all objects to be particles, which do not rotate or anything.
Yes, sir.
Entire block we consider as to be one particle. Entire car we consider to be one particle.
Okay.
Okay. So here, the dp by dt is a second law. Here, there's a more simplified way to it, dp by dt. So d by dt of, you know, differentiation, isn't it?
Yes, sir.
So if you have uv rule, differentiation of uv, do you know formula?
Yes, sir. uv dash plus du dash.
v du by dt.
Yes, sir.
Similarly, here we can write it as m into dv by dt plus v into dm by dt, isn't it?
Yes, sir.
In most of our initial cases, initially when we are studying Newton's laws of motion, we consider mass to be constant.
Yes, sir.
But actually, suppose if a truck is going and sand is going out from the truck, there's mass is changing.
Yes, sir.
As a rocket going upwards, there will be fuel coming out, fuel ejected out.
Yes, sir.
There will be ejection through some mass. So there will be change in mass in all those cases.
Yes, sir.
Suppose, but in initial cases of our study, we'll consider mass to be constant. If mass is constant, is a special case. If mass is constant, we consider it to be zero. What will become? Mass is constant means dm by dt is what?
Zero.
Zero. That's it. Awesome. Then this you will study if mass is constant, m dv by dt. That can be written as m into acceleration. Got it?
Yes, sir.
So writing this external force, F net external force, is crucial in getting acceleration of a particle, in understanding the motion of a particle.
Yes, sir.
Now, for writing this external force, we'll have different types of forces, you know. One is gravitational force, electromagnetic force, nuclear force, or weak van der Waals forces. Okay.
Yes, sir.
These are the four types of forces. Have you seen Robo movie? Robo 2.
Yes, sir.
In Robo 2, that he'll explain that there are only 4 forces still now.
Yes, sir.
You remember the dialogue?
Yes, sir.
That 4 forces are these forces: gravitational, electromagnetic, nuclear force, and weak forces, weak van der Waals forces. These nuclear forces are very short range and highly powerful. Lot of high magnitude will be there.
Yes, sir.
Short range, why? So these are the forces that bind neutrons and protons together in the nucleus.
Yes, sir.
Because the radius of the nucleus is very small. You might have studied in chemistry, isn't it?
Yes, sir.
In that small radius only, the neutron will attract neutron also, because they're neutral, but still they attract each other. That is because of nuclear force.
Yes, sir.
As far as scientists say, okay.
Yes, sir.
So proton and proton actually should repel, but they also will be together in the nucleus. These are due to nuclear forces. They are short range, but high magnitude. High. Then weak van der Waals forces between chemical bonds. You might have seen chemical van der Waals forces
Yes, sir.
between molecules. Here in physics, we will study more about gravitational electromagnetic forces.
Yes, sir.
Gravitational force you study in gravitation topic. Isn't it?
Yes, sir.
Then electromagnetic, here in this topic particularly, we'll study tension is an electromagnetic force.
Okay, sir.
Normal reaction is also an electromagnetic force. You might ask me, how, sir, how can they become electromagnetic force? Isn't it?
Yes, sir.
Actually, when you tie a string, that string, each string is taught when you're trying to separate the string, the internal electromagnetic forces, molecular interaction forces between the molecules of the string will actually hang the string together.
Yes, sir.
That is why the tension force is an electromagnetic force.
Okay.
And even surface, when you keep, friction is also an electromagnetic force as far as I remember. When you keep a block on the surface, the molecules of the block will interact with the surface molecules.
Yes, sir.
Here we can consider them electromagnetic forces.
Yes, sir.
Then gravitational force, in this topic we'll have an example of weight. One gravitational force. Because of gravitational force, we get a concept called weight. What is weight force? Tell me. What is it?
mg.
Mg. Here we consider mg, but actually in gravitation we'll understand this g varies with height.
Yes, sir.
In this topic we consider it to be constant.
Yes, sir.
Because we don't consider lot of difference in heights.
Yes, sir.
Mg is a gravitational force, that is weight. And
Yes, sir.
for this to happen, there no need to be any contact
Yes, sir.
between earth and the body. Okay.
Yes, sir.
And next electromagnetic force, we'll study about tension force.
Yes, sir.
Tension force is a pulling force. It's an electromagnetic force. Are you getting revision completely?
Yes, sir.
It's an electromagnetic force. I'm going a bit fast because we'll have to solve problems so that we'll get more clarity.
Okay, sir. Yes, sir.
Yes, I'm going in an overall review kind of thing.
Yes, sir.
Electromagnetic force, it can only pull, it cannot push.
Yes, sir.
Tension can only pull. We can find out the direction of tension by cut pull method. I'll tell you cut pull method. You have learned this method?
No, sir.
Okay. Then what else related to tension? Cut pull method, pull, electromagnetic force. Then suppose you consider this rope. If ideal rope I'm considering as of now. If rope has mass, then tension will vary across entire the string.
Yes, sir.
If it has mass, ideal string means it doesn't have mass. It is not having mass.
Yes, sir.
Massless and inextensible. Why do we take inextensible? I'll tell you a thing. Suppose you catch the one end of the rope, okay?
Yes, sir.
I'll catch one end of the rope.
Yes, sir.
And I run away from your room. So If it is extending, you will sit here only and I will go away from room, isn't it?
Yes, sir.
If it is not extending, what will happen? You also have to come along with me.
Yes, sir.
That means we can relate the acceleration, velocity, position, distance traveled by you and me, by who are connected through rope, isn't it?
Yes, sir.
That is why we consider an extensible point. Got it?
Yes, sir.
Massless also for some cases. If it has mass, you have to solve that kind of problems also, where tension will not be constant through.
Yes, sir.
That is very important. If you have this string has mass, the tension will not be same throughout. If string has mass, tension will not be same throughout the string. Next, you apply force on both sides, the equal force.
Yes, sir.
The tension in the string is T. Ideal string I am considering as of now, okay?
Yes, sir.
That is equal to F. If it is ideal string and you are pulling on just one side, there will not be any tension, okay?
Yes, sir.
Why? Because you see, if you tie a rope, ideal rope you consider. Ideal rope means it doesn't have any mass. You tie a rope to your ceiling.
Yes, sir.
You are not pulling with any force in the bottommost point.
Yes, sir.
Will it exert any force on the ceiling?
No, sir.
No. So that means both the sides you need to apply force, okay? Equal force. You will get tension. You will see some cut and pull method. How you will see? Suppose
Yes, sir.
a string is there. I'll see. Take a block. Do you know how to find out the tension in the string? Okay.
Acceleration is downwards. T is equal to mg plus ma.
You see here. Actually, the block is at rest in this case.
Okay, sir.
How to write the tension is, because many students will do mistakes here, because in the initial stage I also used to do mistakes in writing tension.
Yes, sir.
You cut the string here if you want to find out the tension here at this point. Wherever you want to find out tension, you cut that place.
Yes, sir.
If you cut now, will it look like this or not?
Yes, sir.
Okay. When you cut now, this point, this A point, you cut into 2 points.
Yes, sir.
Now you see, you pull this. This point also you pull. Pulling means what? You pull the string from top. Pull means what? It will come bottom. It will try to pull to bottom point. Pulling
Yes,
this string means what? Is it like this or not?
Yes, sir.
Pulling. I am trying to pull on both points.
Yes, sir.
So now, if you want to draw the diagram, the tension at this point on the upper string will be downwards. The tension at this point on the lower string will be upwards. You got it?
Yes, sir.
If you want to write the force on this block, that will be upwards tension. If you want to write force on this same point in the string, it will be downwards. You got it?
Yes, sir.
Wherever you find out, you can find out like this. So now, just I introduced tension. So now you tell me what is the force on this block. Now I'll try to write it. We know that F net external is equal to dP by dt.
Yes, sir.
In that I consider this mass to be constant 5 kg.
Yes, sir.
Then can I write it as mass into acceleration?
Yes, sir.
Here I'll ask you, I'll show you how to write this free body diagram. So on this 5 kg block, there is a tension. Which direction? You tell me. After cutting upwards. Now gravity, should there be any contact for gravity? Not required.
No, sir.
No contact is required, but gravity will act or not?
Will act, sir.
Weight will act. In which direction?
Yes, sir.
Downwards.
Yes, sir.
Are there any other forces here acting on this body?
Sir?
Are there any other forces acting on this block?
No, sir.
No, then directly net force T upwards positive I am taking. You can take in any direction. If you want to see downward motion and everything, you can say phi g minus T. If you want to see take this to be positive and this to be negative, you can take.
Yes, sir.
I'll show you how to solve in different problems. Okay. So T upwards I took means minus phi g is downwards force.
Yes, sir.
Is this the net force or not?
Sir, it's kg, sir.
Huh?
Kg.
Force is what? Phi mg na?
Okay, sir. Yes, sir.
Mg.
Yes, sir.
Phi g I took. T upwards net force. This is positive force. If I take this will become negative force, isn't it?
Yes, sir.
Force is a vector quantity. If I add both the forces, net force is equal to what? Are there any other forces?
No, sir.
Then mass is what? 5 into acceleration is A, isn't it?
Yes, sir.
If the block is going upwards, we'll take like this positive. If the block is going downwards, we'll take it to be negative in this situation.
Yes, sir.
So now, is there any acceleration for this block?
No, sir.
It is at rest.
Yes, sir.
Then the tension will be.
Okay, sir.
You got the answer?
Yes, sir.
If you understand these basic tension problems, you'll be able to understand pulleys also. Cut pull method, if you understand, you will understand pulley problems very easily.
Yes, sir.
P is equal to phi z. So, okay. Then you solve this problem. By keeping your hand, you're taking this upwards. This is 3 kg. This is 5 kg. And whenever you are applying you're taking this with, let me tell you. Okay. So like this, you are balancing. Okay.
Yes, sir.
Just it is at rest. Entire system is at rest.
Yes, sir.
You tell me, will this tension and this tension same? They're two
Sir,
strings.
which, sir?
This tension and this one. Tension and this
No,
one.
sir. No, sir.
Why? Because there's a mass in between.
Yes, sir.
So if there's no mass, ideal string is there, entire tension is same, will be same. If it is ideal.
Yes, sir. Yes, sir.
Okay, now you tell me, then this you consider a T1, this you consider a T2, okay?
Okay, sir.
You tell me T1 and T2. But for me, free body diagram is important. If you solve the wrong question as wrong, it's okay. But trying
Okay, sir.
to write down the free body diagram is important.
Yes, sir. Hmm?
First, you write a free body diagram on 3 kg.
Yes, sir. T1 is 3G.
T1 is
3G.
okay. T2 is
There is it 8G or
T1 should be
T2. I don't know how to find it.
okay. T1 you got how much?
3G.
Here, whenever you are writing, first in the beginning you will take practice, then your mind gets habituated to how to see these things. 3 kg, I'll see what all the things are there on 3 kg block. Just you separate this 3 kg from entire world
Yes, sir.
and try to see what all the forces existing here.
Okay, sir.
There's a rope, there's gravity acting on it because gravity doesn't need to be in contact.
Yes, sir.
3g
Yes, sir.
downwards. There is a rope above it. If I cut and see, if I cut and pull, the direction will be upward.
Yes, sir.
It can only pull, it cannot push. Okay.
Yes, sir.
There's a rope below it or not?
Yes, sir.
That rope, if you cut and pull, which direction it will be there?
Upwards.
Upwards, is it? On this block.
If you cut and pull downwards, sir.
I cut Ray, so then what will be there? Like this. This on this 5 kg block, it will be upwards. On this 3 kg block, it will be downwards, isn't it? Or not?
Okay. Yes, sir.
You got it or not? I told you cut.
Yes, sir. Got it, sir. Yes, sir.
This 3 kg, this string will be pulling 3 kg, and that string also will be pulling 3 kg.
Yes, sir.
It will be pulling upwards, it will be pulling downwards. Got it?
Yes, sir.
You understood the importance of this cut and pull method now?
Yes, sir. Got it.
Now this will be T2. How much T2? This will be T1. Got it?
Yes, sir.
Now on 5 kg, I'll write 5 kg. Cut and pull means which direction?
Upwards.
5G will be downwards. Is there any other force acting here?
No, sir.
So now net force on this block should be what? 0, because the mass, it's not accelerating. Net force is equal to mass into acceleration.
Yes, sir.
Then can we write it as T2 minus 5G is equal to 0?
Yes, sir.
Then T2 is equal to 5G. Can we write like this?
Yes, sir.
Got it?
Yes, sir.
Then I will go to upward point. Here, what is the force? T1 is upwards, 3G is downwards, minus T2 is downwards is equal to what? 0, because it is also at rest.
Yes, sir.
Then T1 is equal to what? 3G plus.
T2.
What is T2?
5G.
So entire 3G plus 5G is equal to what? 8G. T1 will be 8G. T2 will be 5G.
Yes, sir.
There are some students, after getting habituated with all these things, they'll try to draw the system properly. If you take this entire to be system, because then this tension is an internal force, isn't it?
Yes, sir.
Will internal force cause any acceleration of the system?
No, sir.
Only external force causes. Only external
Yes, sir.
force is equal to mass into acceleration plus P into dm by dt. So if we consider 3 kg, 5 kg to be system, entire string is ideal. So the entire system can be rated as 8 kg.
Yes, sir.
For the entire system, this T2 is internal. For 5 kg, T2 is external. You got it?
Yes, sir.
If you take only 5 kgs to be in consideration, T2 is there, external force.
Yes, sir.
And if you take only entire 3 kg and 5 kg to be system, then T2 is internal force. You got it?
Yes, sir.
It's like if your father beats you, it's an external thing to you.
Yes, sir.
But if your entire, for me, you and your father, well, if your father beats you, that's an internal thing.
Yes, sir.
If you take your entire family to be a system and no one has bet you,
Yes, sir.
okay. Just I try to just give
Yes,
a
sir.
reasonable example. For this 5 kg, T2 will be external.
Yes, sir.
But when it comes to this entire 8 kg system, T2 will become internal. T1 is the only external force.
Okay.
That is why free body diagram writing should be very nice. You should be able to draw it nicely. The T1
Yes, sir.
upwards, 8G downwards. So some students will solve like this. T1 minus 8G is equal to 0 here. T1 is equal to 8G. Like this also you can get 8G.
Yes, sir.
But in the beginning, I'll encourage students to write like this so that they will not write mistakes in writing down tensions.
Okay.
Later on, you will get habituated in finding out systems.
Yes, sir.
Okay. Then you tell me. Then whenever, suppose like this, a block is given. If a person is applying 120 Newton force, Okay.
Yes, sir.
If a one person is don't write acceleration in free body diagram. Okay, you got it.
Okay, sir.
Only write forces. That is equal to mass into acceleration.
Yes, sir.
So this 120 Newton force, whenever a person is applying on the topmost point, whenever this end of the string is pulled with 120 Newtons force, that entire string will get tension to be that force. Okay.
Yes, sir.
This point you should understand.
Yes, sir.
This entire force will become, entire string force tension will become that 120 Newtons.
Yes, sir.
Now you tell me what is the acceleration of the block, in which direction it will be there.
Yes, sir.
You draw the free body diagram, you'll be able to get it.
So 14 meter per
14.
square.
I'll write
14 meter per second.
40.
14 meter per second.
14. Okay, let me see. So if we take the 5 kg system to be free body diagram, then what will be the tension here? Entire string will get 120 Newtons.
Yes, sir.
Downwards is 5g.
Yes, sir.
Is there any other force?
No, sir.
120 minus 5g is equal to what? 5 into a.
EA.
So 120 minus 5g is what? 50. So 70
Yes, sir.
is equal to 5a. So 5 ones are 5. 5 fours are 20. That's it. 14 meter per
Yes.
second. Got it. That's awesome.
Yes, sir.
Now, okay, I'll tell you a question. The force is acting, okay? The question is asked, entire system, entire these blocks
Yes, sir.
are moving upwards. Upwards with constant velocity, okay?
Yes, sir.
What is, two questions I will ask you. What is F? Okay. What is F? Okay.
Yes, sir.
Other question is, what is net external force? Or otherwise net force acting on the system. Okay.
Yes, sir. So will it be like the same case when a block of mass lesser than the first block is there, sir?
Huh?
So you gave an example, no, sir, 3 kg, 5 kg blocks.
Uh,
Will it be same like that for this when there's a block of mass lesser than the first block, sir?
anything can be possible. You can,
Okay, sir.
any number of masses you follow the system. You don't try to follow exactly what I did, but you understand whatever the concept I taught you and solve this.
Okay, sir. Yes, sir. So total force is 18G, net external is 10G.
Net external is
10G.
okay. You carefully try to understand. Why did you write 18G?
Sir, by solving separately for 3.
Not required. Okay. Let me see. Okay. First, what is a simple cases? I'll try. If I consider this entire system to be entire blocks to be in one system,
Yes, sir.
because they're all going upwards only.
Yes, sir.
All motion can be described in one way. So if 5 kg, 2 kg, 3 kg, what this tension? Suppose T1 I consider, this is T2, this is T1, T2, T3, okay?
Yes, sir.
So T2 and T3 are what? Internal forces.
Yes, sir.
Then because of internal forces, will there be any acceleration or anything?
No,
No.
sir.
Then this 5 to 7, 7, 3 is 10 kg. So can I write it as 10 kg like this?
Yes, sir.
Upwards is what? That is T1. T1 is nothing but that force or what? Nothing. T1 is equal to force. Na? I told you that force will become the entire string tension.
Yes, sir.
Force. What is
Yes, sir.
downward? This is 10G, isn't it?
Yes, sir.
Now the question is F minus. F is nothing but T. Okay, the tension on that string.
Yes, sir.
Because this topmost string, entire topmost string will get the tension as force. Okay, F.
Yes, sir.
I told you this, na? This 120 Newton. If I give entire string got 120 Newtons.
Yes, sir.
In the previous case, like this here, you saw. If I am pulling it with 120
Yes,
Newton
sir.
force, this entire string got 120 Newtons tension.
Sir.
Similarly, here you see F minus 10G or otherwise T minus 10G is equal to 10 into A or not.
Yes, sir.
What is the acceleration here? You tell me for the system.
Constant, sir.
Acceleration is constant.
Zero.
Acceleration is 0. Then F is equal to what?
Yes, sir.
10G. That means
Yes,
uppermost force is equal to 100 Newtons. Or tension
Yes,
in the uppermost string is equal to 100 Newtons. Okay. T1.
yes, sir.
If questions are asked, what is T2 and what is T3? You can get easily. T3, if you want
Yes,
to get T3, you have to draw free body diagram for 3 kg or not, isn't it?
Yes, sir.
So 3 kg downward force is 3G.
Yes,
Tension,
sir.
cut and pull, okay?
Yes, sir.
So T3 will be upwards. So T3 minus 3G
Yes,
is
sir.
equal to what? 0 because it's going with constant velocity.
Sir.
Because it is going with constant velocity, entire block system.
Yes, sir. Yes, sir.
Acceleration
Yes,
is 0. Then T3 will become what?
3G.
3G. T2 I will try to draw. For T2 to get, I have to draw 2 kg block free body diagram.
Yes, sir.
Upwards is T2. Are you getting whatever I am teaching?
Yes, sir.
Upwards
I did by
is
this method.
uh,
I did separately for all these.
T2 is upwards. Tell me, 2G is downwards.
Down 2G.
Are
Yes,
they,
sir.
and is there any other thing?
Yes, sir. T3.
That's it.
T3 downwards.
That's
Yes,
it.
sir.
Awesome. Then T2 minus 2G
Minus
minus
2G
T3
minus T3.
is equal to 0 because it's going with constant
Yes, sir.
velocity. T2 is equal to 2G. 2G plus T3 is nothing but 3G we got in the previous body.
Yes, sir.
Like this here.
Yes, sir.
Then T2 is equal to 5G, is it?
Yes, sir.
That is nothing but 15 Newtons here. T3 is 30 Newtons here. T1 we got 100 Newtons, okay?
Yes, sir.
or that force is 100 Newton. But the question here is, my question is, what is net external force? Net force. What is net force?
Net external is T1, no, sir.
Net force on the system.
Means total force, sir.
Total force.
18 Newton, 18 G.
You be careful here. T1 is upwards,
Yes, sir.
10 kg downwards, 10 G for the system.
Yes, sir.
What is net force here? T minus, that is T or T1 minus 100
Yes, sir.
is equal to what?
0.
Why 0 you write? Because there's no acceleration.
Yes, sir.
Is this the net force on the system or not?
Yes, sir.
Net force on the system. T1 is an external force. 100 also external force. But net force is how much?
0.
0. Because it's going with constant velocity, net force should be 0. That is simple as that.
40.
But if question examiner asks, what is this force, this F force or T1, that is equal to 100 newtons, that we'll accept. What is T2?
Yes, sir.
Then the answer is this one. T2 is 5G, 50 newtons. What is T3? 30 newtons.
Yes, sir.
What is net external force or net force acting on the entire system? Net force is nothing but what?
0.
T is upwards, 100 is downwards, that is equal to 0, isn't it?
Yes, sir. Yes, sir.
This question is asked in 2017 NEET. Nothing here, constant velocity is
Okay.
the point to be noted.
Yes, sir.
Some of the students directly solved what is this F force and they wrote the answer F answer, 100 newtons.
Yes, sir.
That is given in option.
Yes, sir.
You got the point?
Yes, sir. Got it, sir.
Question, you should be very carefully studying NEET especially. Simple questions will be
Yes,
asked
sir.
on simple fundamentals. Not a huge amount of solving.
Yes, sir.
Okay.
Yes, sir.
Then, in the similarly, I'm so hungry now actually. Yes, sir. Similarly, you can draw normal reaction questions. Normal reaction is an electromagnetic force.
Yes, sir.
And then it can only push.
Yes, sir.
It will act perpendicular to the surfaces in contact.
Yes, sir.
Surfaces in contact. So if contact is not there, normal reaction is 0. Okay.
Yes, sir.
For normal to happen, there should be contact.
Yes,
That
sir.
is why it is also called as normal contact force. Okay.
Yes, sir.
Normal contact force. Then it will act perpendicular to the surfaces in contact. Then it can only push. What? And it's an electromagnetic force. And it is self-adjusting force. But it can go from 0 to infinity.
Yes, sir.
Why? Because you see, suppose you keep a suppose I'm trying to example this. Suppose you are standing on the ground. For you to be rest, what are the forces acting on you? Gravity is acting on you.
Sir,
Did you write this? It is self-adjusting force and 0 to infinity.
yes, sir.
You try to be carefully. You try to understand this point carefully. Okay. What are the forces acting on you? You tell me. Gravity is
Force.
gravity is acting on you. Okay. What are the
Weight of the person.
that is nothing but gravity, na?
Okay, sir.
Hmm.
So normal is acting perpendicular to.
Why? Because you are in contact with the surface, and surface will exert force perpendicularly to the
Yes, sir.
contact.
Yes, sir.
Here you consider you are just standing straight, so this will act perpendicularly, normal. Okay. And what else?
Yes, sir. That's it, sir.
That's it. Okay. Suppose then, are you at acceleration? Are you going upwards or downwards?
Upwards.
Are you going? Just you are standing on the ground.
Yes, sir. Okay.
You are standing on the ground. Is there any acceleration to you?
No,
Upwards
sir.
or
No, sir.
downwards?
No, sir.
Then here, Hassan, carefully you understand another point. You might say equivalent Newton's third law states equal and opposite forces will act. This ground will also sorry. On ground also there will be a normal reaction acting.
Yes, sir.
Then this isn't it?
Yes, sir.
So then this normal and this normal should cancel out each other.
Cancel each other. Yes, sir.
But actually they will not cancel.
Okay, sir.
Why? Because this normal is on ground.
Yes, sir.
This normal is on the void.
Yes,
They
sir.
both are acting on different bodies, not on the same body. This is a very crucial NCERT point.
Yes, sir.
These two forces are not acting on the same body. This normal is acting on ground and this normal is, they might be equal. Magnitude wise, they might be equal.
Yes, sir.
But they both are acting on different bodies.
Yes, sir.
If I keep a ball here, for suppose, I and you both are trying to pull this ball in opposite direction, but the ball is at rest. That means whatever forces we both are exerting is not equal to 0, cancelling.
Yes, sir.
Because we are exerting on the same ball, two forces in opposite direction.
Yes,
You got this
sir.
point or not? You tell me.
So once more, can you repeat, sir?
Okay, I'll try to tell you.
Why the normals won't cancel each other?
I'll tell you. When you draw the free body diagram on ground, for ground, you will get this normal reaction.
Yes, sir.
This normal reaction is the external force to the ground, which
Yes.
actually pushes it downwards. Because the contact is there, contact points, it will push downwards.
Yes, sir.
If you draw the free body diagram of man, only man, the normal acting will be pushing it upwards. You got it?
Yes, sir.
This normal and this normal are acting on two different bodies.
Okay, sir. Yes, sir.
You got it? Two different bodies. If they're
Yes,
acting
sir.
on the same body, then we can say they like this 5 kg block is there. Suppose you got
Yes,
it
sir.
here 3 Newton, something 30 Newtons per suppose, 16 Newtons per suppose. Here
Yes, sir.
acting is 16 another 20 Newtons. Okay.
Yes, sir.
These two forces are acting on this 5 kg block.
Yes, sir.
This 60 and 20 are external forces to this 5 kg block. Is it okay?
Yes, sir.
Now this 2 kg block, another block I'm keeping here. There will be 20 newtons, which will be acting only on this 2 kg.
Yes, sir.
This is not an apparent example. I'll try to solve. When you are writing free body diagram on Hassan, I need to carefully understand only forces, external forces on you, not on me.
Okay, sir.
More proper example, I'll take. We both went to a hill. There's enough space for both of us to stand. There's even not even an inch extra for us.
Yes, sir.
I push you, suppose. You will also push me because the equal amount of force will be applied by your body on my body. Na?
Yes, sir.
Will we fall or do not fall? You tell me first.
Won't fall.
We will fall.
Okay, sir.
We both will fall, isn't it?
Yes, sir.
But in your case, normal should cancel out each other, isn't it? Whatever you're thinking.
Yes, sir.
Why do they do not cancel out each other? One normal force is acting on me, other normal force is acting on you.
Yes, sir.
If we consider this both to be a system, then this normal will be zero. Net normal is zero. But if we consider only this boy, on this boy this
Yes, sir.
normal is acting. On this boy also normal is acting. Some.
Yes, sir.
You might say this normal is given by this boy only. What is acting on the other boy? And this normal
Yes,
is
sir,
acting.
but they're acting on two different bodies.
When you're writing only this particle, you need to find out only forces which are acting on me, not which forces I am exerting.
Yes, sir.
I am exerting force on you. That doesn't come into my free body diagram.
Yes, sir.
My free body diagram will only give information about what all the other forces acting on me externally.
Okay, sir.
That second normal is acting on you, not me. Got it?
Yes, sir.
So that is why they do not cancel out each other. In third law, for equal forces and opposite something will be there. Na? What is this?
Yes, sir.
Acting equally and opposite. But they do not cancel out each other because they act on
Yes,
two
sir.
different bodies.
Yes, sir.
This is an important. Like this here, block is there. Mass M is there. So on this body, normal is acting. That will it be cancelled? No, isn't it?
Yes, sir.
Mg will be acting downwards. Is there any other forces? No. And whatever this M,
Normal of ground.
this will be on ground. We are not
Won't cancel the other. Yes,
this
sir.
will
Yes.
not be ground. We are not considering. Only block we want to study now.
Yes.
When we are writing only for block, only we have to write on block, not anything that is given by block. Not required.
Yes, sir.
Then n minus mg is equal to what? 0. Block is at rest.
Yes, sir.
N is equal to what?
Mg.
And in this case, mg it has become. You don't remember it to be mg always. Okay.
Yes, sir. Yes, sir.
People will do mistake. Now I'll tell you another point. So exactly on this block, you kept another m1, m2. Okay.
Yes, sir.
Now, if we consider this entire system, so there will be normal downwards, isn't it? Sorry, normal upwards.
Yes, sir.
M1 plus M2 G downwards, isn't it?
Yes, sir.
you might ask me, Hassan, sir, there will be normal contact force here also, isn't it?
Yes, sir.
But here I took M2 and M1 as entire system. I combined both of them to be system.
Okay, sir.
So that is why this normal will cancel out each other. Does not cancel, but normal is an internal force.
Okay, sir.
I will not consider that force because it's an internal force between M2 and M1.
Yes, sir.
Like how I did not consider you saw a problem. When I'm drawing only this block, I consider this tension. When I'm drawing this block, I consider this and this. When I'm drawing this block, I consider this and this. But when I'm taking entire system, did I consider this and this?
No, sir.
Why? Because they become internal forces. Okay.
Yes, sir.
M1 plus M2G. Now M is equal to what? M1 plus M2G or not? By ground on this
Yes, sir.
on the this surface,
Yes,
this surface force.
Yes, sir.
Now you see, previously it is mg, now it become m1 plus m2g, isn't it?
Yes, sir.
Even if you keep some 1000 kg also, it will increase normal reaction.
Yes, sir.
Even if you keep 1 million kg also, normal reaction will increase or not?
Yes, sir.
That means, is it self-adjusting or not?
Yes, sir.
How much we require, that much it will give, according to the situation.
Yes, sir.
So it can go
Yes,
to
sir.
infinity also, it can become zero also.
Okay, sir.
Okay. Now, the point is, you got this how to write, I'll take a simple block system, 2 kg. You got it, simple case, this is 2g, upwards is normal, n minus 2g is equal to 0, n is equal to 2g. You got it, simple case.
Yes, sir.
Now I'll give you a problem wherein 3 kg, 2 kg. Here you tell me normal exerted by ground on 3 kg block, normal exerted by 3 kg block on 2 kg block. You got it? There will be contact force here also, na? Because there is a contact here.
Yes, sir.
There is another contact here. So this N1 I took this N2 I took. You tell me what is the relation between what is N1, what is N2? Both are equal or not? You tell me just to solve this problem. Today we'll take this to be the last problem.
Yes, sir.
You did not practice these kind of questions, Hassan?
No, sir.
Okay, okay. But you might have seen these problems in your exams, isn't it?
Yes, sir.
You couldn't solve them, isn't it?
Yes, sir.
Okay. We'll become perfect. You take all the papers on
Okay.
this concept. You will be able to easily solve them.
Yes, sir. Yes, sir. Normal exerted on 3 kg block is not considered, no, sir.
This N1 will be on ground also. That will not be considered. Ground we will not take.
Okay, sir. Yes, sir. Sir, N1 is 3G and N2 is 5G, sir.
Here only you are making again mistake. Suppose TK. I'll try to see here. On 3 kg block, what are the forces acting? Okay.
Yes, sir.
There will be N1 acting due to ground on this block. There will be 3G acting downwards. Is it okay or not?
Yes, sir.
Then there will be N2 acting downwards. Why? Because this 2 kg block, this N2 will push 3 kg down and it will push 2 kg up.
Okay.
Like tension, what did it do? 2 kg tension. It is pulling this 2 kg block upwards, this T1, and T2 is also pulling this downwards, 2 kg block, isn't it? Tension is only pulling on the
Yes,
same.
yes, sir.
You got it?
Yes, sir.
Like how you saw this, suppose 1 kg block is there. This 2T is pulling
Yes,
2 kg downwards, this T2 is pulling this 1 kg upwards, isn't it?
Yes, sir.
Cut and pull method. In a similar manner, this normal N2 will contact is there perpendicular to the surface, means like this, okay?
Yes, sir.
Push, perpendicular to the surface and push. Push means what? Downwards.
Yes, sir.
For 2 kg block, perpendicular to the surface means what? Push, upwards.
Yes, sir.
You got it? Now I'll try to sir. This is N2. So this entire body, 3 kg is a thrust, isn't it?
Yes, sir.
Then N1 upwards minus N2 downwards minus 3G downwards is equal to 0. Got it? Are you getting or not, Hassan?
Yes, sir.
N1 is equal to N2 plus 3G. Let me wait still. Now 2 kg block LC. 2 kg block, what are the forces? 2 kg block, the contact force is how much I took. N2.
N2.
So N2 will be upwards and 2G will be downwards. Is there any other force
Yes,
acting? N2 minus
No,
2G is equal to 0. Here, because body is at rest, N2 is equal to 2G. If we substitute
Yes.
this in this first equation, we'll get N1 is equal to 5G. That is 50 newtons. This is 20 newtons. You got it? How to solve the problem?
Yes, sir.
How
Yes, sir. Got it.
to be careful in writing, because if we take only 2 kg to be mass, then N2
Okay,
will
sir.
become external force.
Yes, sir.
If we consider this entire system, then N2 will become internal force.
Yes, sir.
At the time, see, if I solve this question, if examiner only asked me about N1, after a lot of practice, what will I do? This 5 kg to be system I consider, because N2 is an internal force.
Yes, sir.
Then this will be 5G downwards, N1 upwards. So N1 minus 5G is equal to 0. N1 is equal to directly 5G. You got it. You got the answer now.
Yes, sir.
But you carefully understand how to draw these normal reactions and all.
Yes, sir.
If you get clarity till here, we'll proceed forward and solve the other questions also. This is very critical, right?
Okay,
The
sir.
free body diagram. If we are clear with this free body
Yes,
diagram,
sir.
we'll be able to solve any kind of problems in following topics.
Yes, sir.
Friction also will be
Yes, sir.
confusing. It seems that you are confused in friction also, maybe,
Yes, sir.
because if you are not able to draw free body diagram properly, your friction questions also will be tough. Will go tough.
Okay, sir.
Okay. Did you understand, Hassan, whatever I taught you today?
Yes, sir. Yes,
Should
sir.
I-
Understood, sir. Yes, sir.
Should I upload this lecture also, so that if you have any doubts, you can see afterwards?
Yes, sir.
Okay, I'll try to upload it as soon as possible.
Yes, sir.
Okay,
Yes,
okay,
sir.
Hassan. Thank you.
Thank you, sir. Thank you, sir.
Hmm.